Alright, let's look at this problem together. So here we have to consider the diagram for this pendulum in motion, noting that the horizontal position will measure by this variable d, where when the pendulum is at equilibrium or at rest, the horizontal displacement is 0. To the left will count as a negative displacement, and to the right will count as a positive displacement. So our question asks, suppose the pendulum is at equilibrium position and moving left when t equals 0. Further, suppose the pendulum is at most 6 inches horizontally displaced from equilibrium and completes one cycle of motion in 2 seconds. Determine the equation for horizontal displacement of pendulum. Alright, so note a couple things here. So note that the pendulum is at most 6 inches horizontally displaced from equilibrium. This says that our maximum distance, say this maximum distance here, or this maximum distance here, is 6 inches. What else do we see? We complete one cycle of motion, in 2 seconds. Well, what does that tell us? That tells us about our period, right? If we have our period, we complete one period in 2 seconds, that means our period is of length 2, or 2 seconds. We know that for our function, we'll eventually want to determine some d of t equals a times a trigonometric function evaluated at omega t. And we want to determine this omega by looking at our period, noting that our period is equivalent to 2 pi over omega. And solving for omega here, we can find that omega must be equal to pi. So we've determined omega. Note also that we can determine the absolute value of a by considering these maximum displacements away from 0. We can see our amplitude must be 6. So what we're left with then is determining what we will choose as a sine or cosine function for d of t in our equation for d of t, and also the positivity or negativity of a. See that we know the absolute value of a is 6, but we're not sure if that's a positive 6 or a negative 6. So what we do is we consider the only other pieces of information given to us, and those pieces of information being that the pendulum is at equilibrium position and moving left when t equals 0. So these are our initial conditions. And what do these initial conditions say? Well, if we start at an equilibrium position, we must be some sine function. And if we are moving left, if left is a negative direction, that must mean we're decreasing when t equals 0. So we should have a negative a value there. So what is our equation? Well, our equation should read d of t equals negative 6 times the sine of pi t. And this distance, notice that we're measuring in inches, so we can say that this is in inches, and time would be given to us in seconds. In any case, we find our solution here. Let's give it a box, and we're done.